Good morning to all. I, Dr. Devesh Bandil, Associate Professor in Suresh Gyan, Vihar University. Today, I will discuss about linked list. You know, linked list is the main important topic of data structure and algorithm. You know why data structure algorithm is important. There are so many objective of your data structure and algorithm like you know many course objective of your data structure and algorithm like introduced to fundamental concept of data structure and emphasize the importance of your data structure in developing and implementing the efficient algorithm. And if we will talk about the another objective of your data structure is to develop effective software engineering practice emphasizing such principles decomposition, procedural abstraction, and software reuse. And if we will talk about the outcome of data structure and algorithm, so after study data structure and algorithm, student will able to describe the array, record, linked list, queue, tree, graph, etc. And student will also able to describe common applications of array, records, linked structures, stack, queue, graph, and also student will able to write the programs for your array, stack, and queue and demonstrate the different methods for traversing of tree, compare alternative implementation of data structure with respect to performance, compare and contrast the benefit of your dynamic and static data structure implementation. And also student will able to describe the concept of your recursion, and also student will able to describe the computationally efficiency of the principal algorithm for sorting, searching and your hashing. Okay, you know I had told linked list is the main important topic of your data structure. So the objective of your linked list to understand the concept of your linked list, to understand the how to write the algorithm for your linked list, and if we will talk about the outcome of your linked list after studied the linked list, student will able to node how to your node will connect in your linked list. Also student will able to how many types of your linked list. And now I am discussing about the linked list. First of all, I am representing my PPT. I hope you can see my PPT. So in this lecture, I will discuss about what is a linked list, how to write the algorithm of your linked list, types of your linked list, operations of your linked list. First, I would like to discuss about the linked list. What is linked list? You know, linked list is the collection of your node. Node is the new term in your data structure. Node node will consist from two part. Two part means your first part is for data and second part is for pointer. Data and your pointer will point to the next node. Suppose you are having a list, and as per I had told, your list is the collection of your nodes. Suppose you are having five node in your linked list, and I had also told node is the collection of your two part. First part is your data, and second part is your pointer. And your pointer will point to the next node. Suppose your pointer of your first node will point to the second node, and your pointer of your second node will point to the third node, and the pointer of your third node will point to the fourth node, and the pointer of your fourth node will point to the fifth node. Head head will point to the first node, and also you can say that head is the identification for starting of your linked list. Means if your head is point to the first node of your linked list, that time you can say that that is your first node of your linked list. Okay. And null null is the indication. Your null will point to the last node. As per I had told, your fourth pointer part will point to the fifth node, and your fifth pointer part will point to the null node. If I am talking about the null node, the null node is the identification your linked list have finished. Means your null node will point to the last node of your linked list. Okay. And when you will traverse, traverse is the one of the operation of your linked list. Traverse means you can say that visit to each node. You will traverse the each node. Each node means which node are already inserted in your linked list. Okay. As per I had told, suppose you are taking a five node in your linked list, and you want to traverse the all node. You want to visit the all node. So first of all, you will visit the first node. After that, you will visit second node. After that, you will visit third node. After that, you will visit the fourth node. And after traverse the all node, so what is the indication you have कि your linked list have already finished? That's why your null is point to the last node pointer. Means your pointer of your last node will point to the null. That's why I had told null Null is the indication that you have to traverse the all list. You have to traverse the all link list. You have to traverse the all nodes of your link list. Okay. And now main concept of your linked list, as per I had told, main concept of your linked list, first concept is your link. Each link of linked list can store a data called a element. As per I had told, each link of a linked list can store a data called the element. And next, each link of your linked list contain a link to the next link called the next. Means as per I had told, your node is divided into two parts. Your first part, your first part is for data, and your second part will point to the next node. So here I am talking about the main concept of your linked list. So basically, three terms will use in your linked list. First is your link, second is your next, and third is your linked list. Each link of your linked list can store the data called the element. And next, as per I had told, your pointer of your first node will point to the next node. And if we will talk about the linked list, that is your third concept of your linked list. A linked list contains the connection link to the first link called the first. Means your first node will connect to the second node, your second node will connect to the third node, your third node will connect to the fourth node. These are the three main concepts of your linked list. Okay. Here I am representation of your linked list. Means how to represent your linked list. Suppose I am taking a array. Suppose I am taking a list in which there are three nodes are existing. Means I am taking the three nodes in your linked list. Okay. You know, your first node will connect to your second node. Your second node will connect to your third node. Okay. And your head, as per I had told, head will point to the first node. When I am talking about the head and your null, so there is a two concept in your linked list. Head means your head will point to the first node, and your and your last node will point to the null. Means the pointer of your last node will point to the null. So there are two terms which are useful in your linked list representation: first and your null. Okay, as per I had told, head is the indication कि your head will point to the first node. Okay, means from the head your linked list will start. Okay, and in this given slide you can see your first part of your node is your data item, and your second part of your node is your next will point to the next node. Okay, and after that, if we will talk about the types of your linked list, there are so many types of your linked list. First is your simple linked list. Simple linked list means your item navigation is forward only. Item navigation is forward only means your first node will connect to the second node, your second node will connect to the third node. And after the simply linked list, I am talking about the doubly linked list. Okay, doubly linked list, as the name implies, doubly. Doubly means your double. Means item can be navigated from forward and your backward. But in your simple linked list, item can be forwarded. Item navigation is forwarded only. And in your doubly linked list, item can be navigated forward and backward. Means you can navigation the item from forward and also from your backward. And if we will talk about the circular linked list means your circular linked list. Circular. Circular means in your circle shape. Okay. Means last item contain link to the first element. You can understand in your circle way, your last item of your linked list will connect to the first item of your linked list. That is your circular linked list. Here I am only giving the overview of your type of your linked list. I am not explaining in detail types of linked list. Only I am giving the overview of your only singly linked list, double linked list, and your circularly linked list. As per I had told, in your singly linked list, your item can be navigated as only forward, not backward. Listen carefully. In your singly linked list, your items can be forward. Item can be navigated only forward. And in your doubly linked list, you can your elements can be navigated from backward and your forward. Okay, and in your circular linked list, in your circular linked list, your last node of your linked list will connect to your first node. This is your circularly linked list. And how many operations are can we apply on your linked list? So there are so many operations you can apply on your linked list. First operation is your insertion. In your insertion operation, you can insert the node. You can add the node in your linked list. Like suppose you are having a linked list and in which your 5 nodes are already existed. Okay, and you want to add the other node in your linked list. So through the insertion operation, you can insert the node in your linked list. And at this time, your question will arise. You will insert the node from starting end, from last end, and from your middle. So in your linked list, you can insert the node from starting end and from last end and from your middle end. There is no any foundation. that you will insert the node from only last end, from only first end, and from only middle end. There is no any foundation. If you want to add the node in your linked list, so you can add the node in your linked list either from starting end, either from last end, and either from middle end. This is your insertion operation. And if we will talk about the deletion operation, delete means when you want to delete the node. Okay, there, this is your deletion operation. So delete an element at the beginning of the list. I am talking again. Delete an element at the beginning of the linked list. And display means when you want to display the whole complete list, when you want to display the all nodes which are existing in your linked list. This is your display operation. And if we will talk about the search operation, in your search operation, search an element using the given key. Means my means is that you can search the node from your linked list. And delete your delete delete an element using the given key. And your one operation is that traversing. I have already discussed about the traversing operation of your linked list. Traversing means when you will visit the all node of your linked list. Like suppose your linked list having the 5 node, and when you have to visit the first node, after that second node, after that third, after that fourth, and after that your fifth node. So that time you can say that you have to visit the whole linked list. You have to visit the all nodes which are residing in your linked list. You can see in this given slide, suppose I have in this given slide I had taken 2 nodes. Okay, you can see your first node. First of all, your head will point to the data item of your first node, and your next part of your first node will point to the second node. Means here I want to describe कि in this list I had taken the 2 node, and you want to insert the other node in your linked list. As per I had told, you can insert the node from starting end, from last end, and from only middle end. And I had already discussed about what is your null and what is your head. So I think no need to describe head and null. And you can see in this given slide, when you will insert the new node. Okay, in this given slide, your first node and your second node, your first next pointer of your first node will point to the second node, and your uh, when you have to insert the node in your linked list, the next part of your node will point to the next node. And also, if you want to, as per I had told, you can insert the node from also middle end. In your given slide, when you will insert the node from the middle end, your next pointer of your inserted node will point to the next node. Okay, and now I am talking about the implementation of your linked list. Means how to implement the linked list. When you will take the linked list, so first of all, node is required. So first of all, you will create the node in your linked list. So how to create the node in your linked list? How to create the node in your linked list? Because your linked list will consist from the node. Without node, your linked list is your nothing. So when you want to display the linked list, so first of all you will create the node. And how to create the node? So you will create the node with the help of your structure. And the keyword of your structure is that struct. So you will write struct node. And you know your node will consist from two part. Your first part is your data, and second part is your non next, as per I had told. So first of all you will take the data of integer type. And you will take the node, and where you will take the your pointer, your next pointer. Okay, so also you will take your next variable as your pointer type, right? Means when you will implement the linked list, so first of all you will create the node. Okay, that's why if we will talk about the pre-requesty of your linked list, so your C and C++, and also you can say that any programming language is the prerequisite of your linked list. Because in your data structure you will write the algorithm. And your algorithm will implement in any programming language, like your C, C++, Java, Python, C sharp, etc. And there is no any foundation that your language will develop only in this language, your algorithm will develop only in this language. You can implement the algorithm in any other language, but mostly algorithms are implemented in your C and C++. That's why I am saying the your data structure and algorithms courses prerequisite are your C and C++. Okay, and so when you will implement the algorithm of your linked list, you will take the node, you will create the node with the help of your structure. And you will suppose you are taking the three node in your linked list. Okay, so first of all your head pointer of your first node assigned to your null. Your second pointer of your node will assign to the null. And your third pointer sorry, your pointer of your third node will assign to the null. Okay, after that you will allocate the three nodes in your heap. you know when you will take the any variable, so your variable will take the space in your memory. This is your fundamental truth. When you will create the variable, your variable will take the space in your memory. Right? If you are taking the three node in your linked list, so your node will allocate in the heap, and we will allocate the space for the three node. Your for your first node, for your second node, and for your third node. Okay. For your head, your head will point to the first node. You know how to allocate the memory. The malloc is the function through you will allocate the memory. So first of all, you will create the memory. You will allocate the memory for the first node, which will point to the head through the malloc function, and in the same manner, you will create the memory for your second node with the help of your malloc, and you will create the memory for your third node. Okay. And first of all, you will assign the any value. I am assigning the 1 to your first node. They will point to the head, and your second second to the next. Means first of all, you will assign the data to your node, because I had told your node will consist from two part. First your data, and second your link. So first of all, you will assign the data. First of all, you will insert the data in your first node, right? And after that, your link first node. Okay, first of all, you will insert the data. First of all, you will assign the data to your first node, and after that, link from the first node. Okay, link from the first node means your first node will point to the second node. Okay, data has been assigned to the sorry data has been assigned to the data part of your first node. Okay, and in the same manner, you will insert the data into your second node, and your next pointer of your second node will point to the third node. Obviously, main key point is that when you will write the program for your linked list, so first of all, you will create the node. After that, you will insert the data in your first node, and you will insert it in your second node, and you will insert the data in your third node, right? And in your first node, you will assign the data. Okay, and your next will point to the second node. And in the same manner, you will assign the data to your third node, and your next pointer of your third node to point to the null, means equal to assigned to null. Here, when I am talking about the three nodes in your linked list, so there are only three nodes in your linked list. Okay, means the pointer of your third node will point to the null. I had already told your null is the indication of you have to visit the all nodes. Your linked list had already finished. Okay, that's why I am saying your next of your third node means your null will assign to your next of your third node. Okay, and after that you will display. Okay, so means in this way you can represent the linked list. You can develop the program for your linked list. Okay, and after discussed about your linked list, your what is linked list, how many types of your linked list. You know, in this lecture, I am only, I am giving only, I had to only given overview of your types of linked list and about the After discussion about a linked list, I want to discuss some questions which are based on your linked list as per share my screen. Like which of the following is not a disadvantage of the use of memory? Fixed size, there are chance of wastage of your memory space if elements inserted in an array are less than your allocated size. Obviously your answer will be accessing elements at a specified position. And which of these is not an application of your linked list? So, your random access of elements is not an application of your linked list. About a linear data structure, array, array, queue, stack, and your tree. So your linear data structure is your tree. I will discuss about the tree in my next lecture. And your character data type have 32 bit size. Obviously your character data type have only one byte. And in a linked list implementation of a queue where does a new element is to be inserted, so at any position in the linked list, as per I had told, you can insert the node at any position. Either you want to insert the node from your first position, you want to insert the from your second position, from your end position, from your only middle position. There is no any foundation ki you will insert the node from only starting position, from only end position. You can insert the node from any position. So I hope after discussed about the linked list, understood about the linked list, how to implement your linked list, what are the operations of your linked list. Okay, and now thank you.